This video will be an enhancement of previous simulations and simplifications. The eye has a visual environment of 0 diopters when looking at an infinity and, for example, 4 diopters when looking at 10 inches. I use a signal of plus and minus 13 volts and divide to plus and minus 4 volts. That signal is then clamped from 0 volts to minus 4 volts, as shown here. That signal is then used to drive the accommodation system, as shown here. I've shown block diagrams of this system previously. The input to the accommodation system then is 0 diopters to minus 4 diopters. Now, this is a living natural eye. It is not an eye that is failing in any way. The simulation is accomplished by the basic feedback elements of an error detector and then a motor which drives the lens of the eye. But the eye has deadband, which causes hysteresis, or oscillation, in the circuit. And this oscillation is expected and demonstrated in the human eye. The oscillation is about 3 or 4 hertz. I'll show results on the oscilloscope for the error signal and then on the output as well as the meter. This simulation shows something called servo-lock, where a step input is responded to and then locked, even though there's dead band in the circuit. So bear with me, I'll show it to you shortly. Here's the signal output, which is the meter, and it shows a looking for 0 diopters, and then the same thing for minus 4 diopters. The eye oscillates briefly around its desired point and then locks at that point and stays there until there's a step change in the environment, or rather the input to the eye. Very standard control system, sophisticated, competent. That is what it does. Here's the error signal. The error signal controls the motor, but it goes through hysteresis, and so you see this oscillation about 3.5 hertz. During the servo step input, you will see an analog response as shown on this meter, and a continuous oscillation due to the searching action across deadband, or the hysteresis circuit. Here's the output of the circuit, and as expected, it goes between 0 diopters and minus 4 diopters, and there's your overshoot searching for and locking on to 0 diopters. And again, of course, for a step input of minus 4 diopters, a change in refraction of 4 diopters. Here's the input to the system. It's plus and minus 4 volts. I have to adjust the ground, as you can see, but that is input to the circuit. It's a basic simulation circuit. Often this oscillation has been seen as a problem of some sort with the accommodation system, but it is not. It's necessary for the good working of the system. Hysteresis is completely normal, is due to aperture effects in a camera, that you don't have accurate focus right at the point of sharp focus. So the system oscillates back and forth across the desired value. I hope this clarifies the whole concept of simulation for a accommodation system in a working model. Thank you.